Okay, I should probably share the link somewhere before I get started. Okay, I've posted the link, all the places I want to, so I guess we'll get started. Yeah, so flashcards first thing. So communication bound means that the T comms is greater than T math. Okay. Commute the arithmetic intensity of this matrix multiplication. Okay. Oh, I forgot I need pen and paper for this. I have paper near to me, but do I have a pen? We'll find out. Okay. Yep, there we are. So, the number of flops we've got, so BF, that's the shape of it, and then for the dot product we're going to need to do D multiplications, D minus 1 addition, so D plus D minus 1. So that's the number of flops, and then the memory reads and writes. We've got 2BD plus 2DF plus 2BF. So the fraction of that, and then we'll simplify it to remove constant factors and also make the assumption that B is much less than D and F. Okay, so it's about B. The arithmetic intensity is basically just the batch size. Okay, yeah, or if they don't use the fully simplified form, yeah. Because what I did was said BD and BF are much smaller than DF, and then you can cancel the DF to get B. I'm happy with that though. Derive a minimum batch size for compute boundedness. Okay, so we just showed that the arithmetic intensity of that matrix multiplication was B, and that's the transformer matrix multiplication that we care about. So B needs to be greater than the arithmetic intensity, the peak arithmetic intensity of the accelerator. Yeah, and typically the value for that is 240, I think. Yeah. Okay. So peak arithmetic intensity is the peak flops per second divided by the like maximum bandwidth of the accelerator. Wait, what? I don't know what's up with Anki. Sometimes it's, yeah. What's the worst case relationship between the upper and lower bound on total runtime? Yeah, so the upper bound can be at most twice the lower bound. Yeah. Compute bound means that T math is much greater than T comms, assuming that they can be, like, the math and communications can both be overlapped. Given the number of computation flops and processor flops, how can we compute the time needed for a program to run? Okay, so it's just computation flops divided by processor flops per second. Yeah. So the weights have to be, some of them need to be positive and some of them need to be negative. Yeah. What's the arithmetic intensity of that operation? Okay, so in terms of the flops, it's just similar to before. So we have BF, and then we would have had to do 2D -1 operations for each element. But then in terms of the memory loading, it's going to be a bit different because we have BD plus BDF plus BF. And then simplifying, getting rid of small terms, we have 2BFD over BD plus BFD plus BF. We'll say that B is relatively small, so that cancelling out the BFD, we get the arithmetic intensity is roughly equal to 2, so it's almost always going to be communications bound. Yeah. Okay, so that's that for review, I guess. And then let's go back to debugging from yesterday. So I guess the first thing to do is so that this stream doesn't get very boring, I'll need to re-edit the data loader such that it doesn't go through all of the images. So like we can just train on like the first 1,000 or something. I don't know how many examples there are actually, but like yeah, we want to just run on a small set to begin with because the reading takes like so long for some reason. Range size. Where's the labels being assigned? Okay, so I guess we'll just take the first K of these. So but then that kind of, because I think, is the problem actually with reading here or like later on when we process? I don't know, we'll see. I'll try this. If this doesn't work to make it a lot noticeably faster, then we'll have to actually stop it reading the whole thing. Yeah, it's still very slow. So it looks like, the thing is it even possible for us to like not read the whole thing? Yes, because we can pass an argument to file.read. And then I guess I need to find out how, because the labels, it should be what, just 8 bits per label, right? Because you don't even need 8 bits, because it's like, the labels are from 1 to 10 inclusive, so you can get away with like 4 bits for that, right? And then, but then I don't know what, we'll have to look up the file like format. And then for the images, that's 0 to 255, so that's definitely 1 byte per pixel, and we know it's 28 by 28. So we know how many bytes are going to be in one image. It's just going to be 28 by 28. So times k, so call that 100, I guess. And then I'll get rid of this here. Let me just cancel this. Okay, and then the fact that it says B already tells us that it's going to be bytes. So we want to read 100 bytes because 100 labels. Hopefully this runs a bit faster. Okay, it did, but then it seems like something has gone wrong. So reshape 2828. Huh. What's going on here? So we're reading the first 28 by 28 by 100 bytes, and then we're indexing it. So image equals image.reshape 28, but then it has shape 0. Hold on, wait.